In Chapter 3, we were shown this table that shows the energy content of different fuels, and in the next video that I make, I'm going to show you where those numbers come from. But before, I just want to talk a little bit about how this table relates to a figure that's in Chapter 5. So these fuels that have to do with the fossil fuels, coal, oil, gasoline, natural gas, we have energies here, and they're in megajoules per kilogram. That's megajoules, which is 10 to the 6, or 1 million joules. And then per kilogram, it's important that we know per kilogram of what, and in this case, it's per kilogram of fuel. And we'll see why that is important in the next video, but it is important that we know that these numbers are per kilogram of fuel. So for example, with coal, this is 29 megajoules per kilogram of coal. And for oil, it's 43 megajoules per kilogram of oil. And oil and coal, because they're different densities, the same number of kilograms is a very different volume when it comes to coal versus oil. So in Chapter 5, Figure 5.7 shows us how much carbon dioxide is emitted in number of kilograms per gigajoule of fuel. So a gigajoule here, just so we remember, giga is 10 to the 9, or a billion joules. Okay, so in this figure, this says that we will get 90 kilograms of carbon dioxide for every gigajoule of energy from coal. And we will get somewhere around 70 kilograms of carbon dioxide for every gigajoule of oil. And then finally, for natural gas, it's around 50 kilograms of carbon dioxide that gets produced by burning natural gas that would produce a gigajoule worth of energy. And so this unit, this kilogram per gigajoule, is what we would call the mathematical reciprocal of these numbers here that are a number of joules or energy per kilogram. So we just need to think about these numbers here. We would have to flip over the fraction in order to get these numbers on this graph. And so we'll see quantitatively how to do that in the next video.